Hello geometry students, and here's your lesson for section 3.5, Slopes of Lines. Missy McCarthy, Okemos High School math instructor. The objective for this particular section should look familiar. The first one is to find the slope of a line. That's something you practiced doing a lot in your previous course. And the second is to use the slopes to identify whether the lines are parallel and perpendicular. And that's the connection to what we've been doing previously in the section, in the chapter. You're going to need some graph paper for this particular lesson. All I did to find some graph paper was I Googled coordinate plane, and then I went to the images. You can see there's several different images that you can use. You can just copy and paste the image into a Word document and then print off graph paper. There's also graph paper available in class if you need it. So let's review what we're referring to when we talk about the slope of a line. Again, these are concepts that you guys learned in algebra, and we've been talking about lines in geometry, but not necessarily lines in the coordinate plane. So when you have a line in the coordinate plane, when you've plotted the 2 points according to the x and the y coordinates, then we can talk about how steep the line is, and the steepness of that line, the way you measure the steepness of the line is its slope. Now the measure for the steepness is the rise, how far, if you start at one point on the line, how far you rise, and then how far you run to get to a second point on the line. So the rise is the difference between the y values on the line. The run is the difference between the x values, and the slope then is the ratio of the rise to the run. The bigger the slope, the bigger the ratio, the steeper the line. So if you have 2 points, x1 and y1, and another point, x2, y2, to find the difference in the x's and the difference in the y's and the difference in the x's, that is how you find your slope. So let's practice just to recall what you guys did last year. If we wanted to find the slope of line AB, we need to know what the coordinates of A and B are. So A has coordinates, I can't even locate point A. I'm assuming it's here because it's the one that's not marked. So the coordinates of A would be -2 and then up 4, 5, 6, 7. -2, 7. And then B is here. The coordinates of that are 3, 7, it looks like. Okay, so if I use my slope formula, the slope is the change in y, so 7 minus 7, divided by the change in x's, so 3 minus -2. I end up with 0 over 5, so line AB has a slope of 0. Now if I wanted to do AC, I'm going to go ahead and label A there. A, once again, we said had the coordinates of 2, 7, and C has the coordinates of 4, 2, it appears. So if I were going to do my slope, it's the change in y, so 2 minus 7, over the change in x, so 4 minus -2, and it looks like we have a slope of -5, 6 for line AC. For line AD, again, point A has the coordinates of -2, 7. Point D in this case is -2, 1. -2, 1. So if we find our slope, it's the difference in y, so 1 minus 7, y2 minus y1, and the difference in x's, so -2 minus a -2, -2 minus -2, and we end up with -6 over 0, which means our slope is not defined because division by 0 is not allowed. So look carefully at line AD. It has an undefined slope. And then lastly, CD. CD is this line here. Point C is at coordinates 4, 2. And point D was at coordinates -2, 1. So if we find the slope here, we have 1 minus 2, the change in y's or the difference in the y's, and then -2 minus 4, the difference in the x's. So that slope is -1 over -6, which is 1. 1/6. So we found the slope of each of the indicated lines. Now, if you recall from the past, when you have a positive slope, that means that your line is increasing. When you have a negative slope, that means your line is decreasing from left to right. When you have a slope that is equal to 0, that means you have a horizontal line. And when you have a slope that is undefined because of division by 0, that means you have a vertical line. Okay, slope can also be thought of not just necessarily the steepness, but can also be thought of as a rate of change. Now remember, rates have different units. It's a ratio, but when the units are different for the ratio, that makes it a rate. So if we look at this problem here, Justin is driving from home to college, to his college dormitory. At 4 p.m., he is 260 miles from home, and at 7 p.m. he is 455 miles from home. Graph the line that represents Justin's distance from home at a given time, and then find and interpret the slope. So the graph is already made for you. 4 hours into the trip, he is 260 miles away from home. Then 7 hours into the trip, he is 455 miles from home. So can we find the slope or the rate of change of Justin's travel? Sure we can. This time I'm going to put the units in there so that we can interpret the slope. So it's again the difference in the y's and the difference of the x's. So we have 455 minus 260 and then 7 minus 4. So 455 minus 260 I believe is 195. And then 7 minus 4 is 3. Now the y value is measured, sorry about that, in miles, and the x value is measured in hours. And so that's how we get our slope as a rate of change in miles per hour. So if I do 195 divided by 3, I end up with 65 miles per hour. Now that doesn't mean that Justin is driving constantly 65 miles per hour. That is his average rate of change. So the average rate of change, average speed between 4 p.m. and 7 p.m. is 65 miles per hour. Okay, now we get to the theorems about parallel and perpendicular lines. As we know about their slopes, now we can see how that applies. Again, information that you're used to or that you're familiar with. The first theorem, the parallel lines theorem, says in a coordinate plane, two non-vertical lines are parallel if and only if, so this is a biconditional statement, they have the same slope. So if they have the same slope, then they are parallel. If they're parallel, then they have the same slope. And it says any two vertical lines are parallel. The perpendicular lines theorem says in a coordinate plane, two non-vertical lines are perpendicular if and only if the product of their slopes is -1. So if the product of their slopes is -1, then they're perpendicular. And if they're perpendicular, the product of the slopes is -1. And it says vertical and horizontal lines are perpendicular. So these two concepts you're familiar with. You just didn't know that they were theorems. But they are indeed the parallel lines theorem and the perpendicular lines theorem. So we can use these to graph each pair of lines and use the slopes to determine whether the lines are parallel and perpendicular or neither. Same slope, parallel, product of their slopes -1, perpendicular, and if neither of those is true, then they are neither parallel or perpendicular. So UV and XY, those are the two lines we're going to take a look at. So U is at 0, 2. There's point U. V is at -1, -1. There is V. And now I can draw a line UV. Then line XY, X is at 3, 1. y is at negative 3, 3. And so then I can draw that line. Now we want to know if those two lines are parallel, perpendicular, or neither. Well, parallel I think is out of the question, but let's check and see if they're perpendicular. So I'm going to find the slope of line UV by doing the difference in the y's, negative 1 minus 2, and the difference in the x's, negative 1 minus 0. So I end up with negative 3 over negative 1, which has a slope of 3. Now I'm going to do the slope of line XY. The slope of that line is difference in the y's, 3 minus 1, 3 minus 1, difference in the x's, negative 3 minus 3. And so I end up with 2 over negative 6, which is negative 1/3. So I'm going to multiply these together. The product has to be negative 1. 3 times negative 1/3 is equal to negative 1. Therefore, we can say that line UV is perpendicular to line XY because the product of their slopes is negative 1 by the perpendicular lines theorem. So for this next one, we have to graph G and H. G is at negative 3, negative 2. H is at 1, 2. So there's our line GH. Then we have I at negative 2, 4. And then J at 2, negative 4. So there's our line IJ. So first I'm going to find the slope of GH. So the slope of GH would be 2 minus negative 2. I'm going to try to write that better. 2 minus negative 2. And then 1 minus negative 3. So we end up with 4 over 4. So it has a slope of 1. And then the slope of IJ, the change in the y's, negative 4 minus 4. And then change in the x's is 2 minus negative 2. So I end up with negative 8 over 4, which would be negative 2. Now if I know they're not parallel, so if I do the product of the slopes, I get negative 2. So they're not parallel. They're not perpendicular because the product's not negative 1. So these two lines are neither parallel nor perpendicular. So rewatch any parts of the video to make sure that you understand what we were talking about, and this should say slopes of lines, not perpendicular lines. If you're watching on YouTube, feel free to type questions in the comments section, and the lesson quiz is on the next slide. There you go.